Hello, welcome to video 2D. I'm Mr. Miller, and I hope you're doing great today. This is about interpreting complex expressions. So we've done some of this before. We're going to have some algebraic expressions, and it's like a puzzle. We have to kind of figure out what they mean. All right, so I think we have two examples here. So here's the first one. So at Ralphie's Grill, hot dogs cost $3.80. Sounds good to me right now. While orders of fries are $2.25 each. Okay, so that's the cost of hot dogs and fries. Here come the variables, right? So let H represent the number of hot dogs a customer orders, and F is going to represent the number of fries they order. Okay, so this time we have an equation. Equation has an equal sign, an expression doesn't. So this is a little bit more than an expression. It's an equation, but we can interpret it. So what does it mean? Well, we have H plus F equals 6. So H is the number of hot dogs. F is the number of fries. This must mean that the total number of hot dogs and fries that were ordered was 6. Okay, so that's the meaning of it. The number of hot dogs and fries they ordered was 6. So it's a given example of an order where that would be true. Well, maybe we have 2 hot dogs and 4 fries. Okay? But as long as those two numbers add up to 6, that equation would be satisfied. Okay, no problem there. Same setup here, same variables. Now we got a little bit uglier equation. So we have 3.80 times H plus 2.25 times F equals 1660. I want to know what this means. All right, well, H is the number of hot dogs, and $3.80 is the price of each one. So if you ordered 2 hot dogs, you'd have to pay $3.80 twice. It'd be 2 times $3.80. If you order 8 hot dogs, this is how much the hot dogs would cost. All right, we're taking the number of orders of fries and multiplying that by $2.25. So this is how much the fries cost. So the cost of the hot dogs plus the cost of the fries equals $16.60. So this is the total cost of their order. So what I'm saying is the total cost of their order is $16.60. So I said, did they order 4 hot dogs and 2 fries? Well, I don't know. We have to put 4 in for H. So we'll do 3.80 times 4. We'll substitute 4 for H. Then we're going to add $2.25, 2.25 times 2. And the question is, does that equal 1660? And I have no idea. So I'm going to grab my friendly calculator here. And we're going to do 3.8 times 4 plus 2.25 times 2. No, that's 1970. So this is $19.70 apparently. So no, that wasn't their order. All right. So they must have ordered a different amount of hot dogs and fries for it to be 1660. The main goal here is actually not to figure out how many hot dogs and fries they ordered in this problem. It's to understand what this equation is telling us. All right, here's another example. Rubio has an envelope of cash, and all the bills are 20s and 5s. So he has an envelope of money with 20s and 5s in it. All right, so we're going to let T be the number of $20 bills he has, and F is the number of $5 bills that he has. Okay, so if T plus F equals 13, what does that mean? Well, it means the number of 20s he has plus the number of 5s he has equals 13. This is the total number of bills in the envelope. It's not how much they're worth, it's just how many bills are in there. Okay, so 13 bills in his envelope. This equation, though, is about how much they're worth. So the same setup, This time we have 20 times t. Well, that's how much the $20 bills are worth. We're multiplying how many 20s he has times $20. So this is the value of the $20 bills. This is how many 5s he has. So if we multiply that by 5, we have how much the $5 bills are worth. So when we combine these things, we get that the total value is 125. So later on in this course, we'll take these two facts. The fact that he has, how many did we say? We said 13 bills. Had to go back and look. And the fact that they're worth $125, we can actually do some math and figure out how many 20s and 5s he had. Right now, we're just about thinking about what the equations mean. Okay, keep practicing your math.